Welcome to another exciting day of exploring what you can do with JavaScript. So far, you've learned how to write programs that let your computer do the math and show messages as alerts. You've also learned how to use the prompt function to get user information. Today, we take it to the next level. We're going to let our computers make decisions. But first, we need to discuss an important programming foundation: algorithms. What are they? Imagine algorithms as a recipe from a cookbook. Each recipe gives you a list of ingredients and steps to create a delicious dish. For example, tasty spaghetti requires pasta, olive oil, garlic, spices, tomato sauce, and maybe some meat. You follow the recipe step by step and end up with a fantastic meal. Algorithms are like just these recipes. They are instructions for your computer telling it exactly what to do step by step to get a specific result using data stored in variables. If you did your homework, you remember there were specific steps: to collect some info, calculate things, and then display it in an alert. You are following an algorithm and instructed your computer to complete these tasks in the right order. So now you can create a simple algorithm and write code to execute it. You are ready to go further. Let's dive into how we can make these recipes or algorithms smarter with conditional statements. These are road signs telling the computer which way to go based on certain conditions. Imagine you want to make spaghetti for lunch, but you want to adjust the recipe based on what you have at home. You open the fridge to check for tomatoes. Do you have any? If yes, you can make tomato sauce. If not, you might make a cream sauce because you have a cream. You choose your next step based on what's in your fridge. Let's say you're making tomato sauce because you found some tomatoes. Now think about who you're cooking for. Just yourself, or will your boyfriend join you for a date and eat with you? If it's just for you, you'd add many spices because you like them. But if your boyfriend is coming, you'd use fewer spices so you both enjoy it. Finally, you want to top the dish with parmesan. You need to check if you have some. If you do, go ahead and add it. If not, just skip it. Now, how would you write this in JavaScript? For the tomato sauce part, you first check for tomatoes. If you have them, you can make tomato sauce. Here's how it might look in JavaScript. This is what we call a conditional statement. We start with the if word and then a condition inside parentheses. Next, inside the curly braces, you write some code to run if the condition is true. To check if something is true, we use three equal signs. We'll explore these comparison operators later in this lesson. How can we write in JavaScript that we actually have some tomatoes? We can create a variable, for example, there are tomatoes, and set its value to true. Okay, so in this example, we have tomatoes in the fridge. Then we check if we have them using a conditional statement, which is true. That means what's inside will happen and we'll see an alert. But instead of just watching slides, let's go to CodePen and play with this example. I'll type this code into the JavaScript panel. What do you think will happen when I run it? If you guessed an alert will show, you're right. Look, it says we have tomatoes, let's make sauce. What if we don't have tomatoes? Now I'll change the value of that variable to false. What do you think will happen when I run the program this time? This time I can wait all day and nothing will happen. The condition is false without tomatoes and the code inside doesn't run. There's no action because the computer only knows what to do if there are tomatoes. How do we handle the no tomatoes scenario in our code? We use the else part of the if-else statement. This lets us handle both possibilities. What to do if the condition is true and what to do if it's false. Let's write this code in CodePen and test it. When there are tomatoes is true, an alert to make tomato sauce shows up. When I change it to false, it alerts that we don't have tomatoes. Everything works correctly. This way you can tell the computer what to do depending on the condition. Let's write another example. Let's check if 5 plus 5 equals 10. Remember, when you write the condition, use 3 equal signs, not just one. In JavaScript, a single equal sign assigns values to variables. It's important to keep this from mixing up. Okay, I've written that condition, created an alert for what should happen if it's true, and set up a second condition for if it's false. I'll run the program now and an alert says it's true. It's correct because 5 plus 5 does equal 10. Let's write a condition we know isn't true, like 2 plus 8 equals 5. In this case, an alert pops up saying it's false. Alright, now you can tell the computer what to do depending on whether something is true or not. So now here's a task for you. You're making spaghetti and you need to decide if your boyfriend is coming over. Based on that, you'll make the dish more or less spicy. Try creating a code in CodePen, just like we did with the tomatoes, but do it on your own this time. Display the right message in an alert for each situation. I hope you didn't find that too difficult. This time, we're creating a new variable, maybe called dinner with my boyfriend. Depending on whether it's true or not, I create the right messages. But what if there are more conditions to check? You want to make tomato sauce if there are tomatoes. If not, you'd make a cream sauce, but only if there is cream. If both are missing, you'll switch up the plan. For such cases, we use the else-if keyword. We use it when there are more than two conditions. Here's what it looks like. First, I check if there are tomatoes. If there are, an alert says I'll make tomato sauce, and the program stops checking the other conditions because it found a match where their condition was true. But if there aren't any tomatoes, the computer looks further. It checks the next condition written with the else-if keyword. It checks if there's cream. If there is, it says I'll make a cream sauce. But if there are no tomatoes or cream, then the last alert will show. You might now wonder what the difference is between the else and else-if cases. With the else-if keyword, you need to check a condition, but if you write just else, you don't check any condition. You can have many else-if cases, but only one else statement. and it covers all unchecked scenarios. Now you understand how to make the computer decide what to do based on conditions. But how do you create these conditions? You know about arithmetic and assignment operators. Now it's time to learn about comparison operators, which helps us test if something is true. Here are 6 important ones. The first is the strict equality operator, which uses 3 equal signs to check if the left side is exactly the same as the right. Another one, a bit tricky, is the strict inequality operator. We write it with an exclamation mark followed by 2 equal signs. It checks if what's on the left does not equal what's on the right. It's the opposite of the strict equality operator. Let's use our tomato example to explain. Using strict equality, we check if we have tomatoes. If there are, we display that we'll make tomato sauce. We've set the variable there are tomatoes to true, so the left side of the operator equals the right side, resulting in true. That means you have tomatoes and can go ahead and make your sauce. But what if I use the strict inequality operator and instead of an equal sign, I use an exclamation mark? Let's say there are tomatoes is still true. I don't change anything except the operator. Here we check if there are tomatoes is not equal to true, which means we don't have tomatoes. In this case, no alert shows up because there are tomatoes is true, so the condition isn't met. You want tomatoes to be missing, but they are in the fridge. Let's look at another example. You want to watch a movie tonight and you want your computer to suggest a good one. But you really don't like horror movies because they scare you too much, so you want the computer to avoid recommending them. This is a perfect job for the strict inequality operator. Here it checks if the movie genre isn't horror. It's a romance movie this time, so the left does not equal the right, which is exactly what we wanted. So you can safely watch it, it's not a horror. The strict inequality operator is great for avoiding things you don't like. Both the strict equality and strict inequality operators work with numbers and text. Here's another example. Imagine it's a movie night and you really want popcorn. If you check the kitchen and find it, you'll see an alert saying, "Great, you got your favorite snack, and you can enjoy your movie with it." But be careful with string comparison. Remember, if there's a typo like writing popcorn instead of popcorn, the strings won't match exactly. Always double check your text. Now that you've learned the most complex operators, the next 4 will be easier. Less than, greater than, less than or equal to, and greater than or equal to. These operators check if something is bigger, smaller, or equal to another value. Let's look at some examples of how they work. First, let's talk about the greater than operator. For example, you play a game, and the rule is that you need more than 100 points to complete it and win. Here's how it looks in the code. In this game, you need to score more than 100 points. If you have exactly 100, you still need more to win. Next, we have the less than operator. To show you how it works, imagine swimming in the sea. You prefer swimming if the water is above 70 degrees. If the temperature is 68 degrees, it's too cold for you. Now let's look at the less than or equal to operator. Imagine you want to go to a movie theater that offers junior discounts for anyone 16 years old or younger. Can you use this discount if you are 16? Absolutely. You can use it whether you are younger than or exactly 16. We can show this with the less than or equal to operator. If you are exactly 16, you still meet the condition. The greater than or equal to operator works similarly. Imagine you visit an online liquor store and the message asks if you are at least 18 years old. If you are, you can enter. We can write this using the greater than or equal to operator. This code means you can enter the site if you are more than 18 years old and also if you are exactly 18. If we used only the greater than operator, then at 18 you still couldn't enter the website. Do you see the difference? Alright, for the final part, I've set up some coding exercises for you to practice what you've learned. Your job is to figure out which alert will show up in each exercise. Here's the first task. Look at the code, pause the video for a moment, and decide which alert will show. In this case, the alert "You are too young to vote" will appear because 16 is less than 18, so the condition is met and is true. Now here's a bit harder second task. Which of these alerts will show up? Pause and try to choose. Take your time and analyze the code. In this example, the alert "It's warm enough for a t-shirt" will appear. Let's explain why. First, we check if the temperature is below 60. It's 75, so clearly it's not below 60. We skip the jacket. Next, we check if it's 70 or below. It's not, so there's no sweater either. None of these conditions apply, so it's t-shirt weather. Okay, and finally the hardest example, but I believe you can handle it. Which alert will show up? Pause again. Don't rush and pick the right alert. Imagine it's movie night at your house. You want to watch an action movie, but when you check, all you can find is a comedy. You can see the strict inequality operator, which checks if two things are different. Here, it checks if the movie you want, action, is not the same as the movie available, comedy. Because they aren't the same, the computer shows the alert. The action movie isn't available tonight. Let's watch a comedy instead. And that's it for this video. Don't worry if you didn't get everything right. This is new for you and you need time to get comfortable with it. In the next part of today's session, we'll also discuss more advanced topics like loops and functions, which will help you create more useful programs. But remember, every complex program starts with understanding the basics we discussed today and yesterday. Feel free to rewatch this video. Also check the MDN web docs for more information and examples. See you in the next episode. Hello and welcome back. Are you ready for more challenges? I hope so, because a new JavaScript adventure is here. Today we're focusing on loops, a powerful feature that allows computers to repeat actions multiple times. But before we get to loops, we need to discuss another fundamental data type I haven't introduced yet to keep things simple: arrays. We'll start with arrays and then progress to loops. Also, here's a quick reminder. You don't have to memorize all this code. Becoming proficient in coding comes naturally with experience and training. So focus on understanding rather than memorization. Are you ready? Let's dive in. Let's discuss arrays, a type of reference data type. First, let's talk about how they differ from primitive data types, which you already know. Primitive data types, such as strings, numbers, and booleans, store a single piece of information. They're like individual boxes for storing items like books or toys. Now, if you have many boxes, let's think how you might organize them. Instead of spreading them around your room, you might put them all on a big shelf, which is what we call an array in programming. An array is like a shelf where you can line up several labeled boxes or things. Each spot on the shelf can hold one box or thing, and you can quickly find any item by knowing its position on the shelf. How to use arrays in programming? When you put an item on the shelf, you decide its position, which is called its index. The first spot is index 0, the next is 1, and so on. Why do we start indexing from 0 in arrays, not from 1? It's more efficient in programming and helps simplify calculations. Don't worry about the specifics right now. It's something you'll get used to over time. Here's a simple way to write it down if you're creating an array. You start with an open square bracket, then you list all the items you want in the array, separated by commas, and finish with a closing square bracket. This example shows an array filled with strings. However, arrays are not limited to strings. They can also hold numbers, booleans, or even other arrays. What's more, you can mix and match different data types within the same array. Arrays are very useful in JavaScript programming. Now, how can we access specific items on the shelf? If you want to know what's in the first spot on the shelf, look at index 0. In our case, it would show books. You can access an item using the index number inside square brackets. It's time to see this in action, right? I'll move this code to CodePen and save our array there. Okay, we have 3 items inside. Now I want to display the first item in the array, books. How do we do that? I'll make an alert that displays this item. To reach the item, I enter the array's name and index in square brackets. For the first item, we type 0. Let's see. And there it is, books in the alert. Perfect! Next, let's display the second item, toys. What index will we use this time? This time it will be 1. And indeed, toys show up. To reach the next item, we type in index 2. Now we have the sports equipment. This way we can access a specific item on the shelf. We'll use it because you can manipulate the elements in an array. You can add new ones, remove some, swap one for another, etc. Arrays help you group items and organize them better. Now let me show you one example. We have our array, my shelf. The elements in it are books, toys, and sports equipment. Let's display it in an alert to see what it looks like. Okay, you see all the items listed one after another, separated by commas, just as expected. Now let's say I want to replace the first item in our array, books, with something else like magazines. How would I do that? First, I need to identify which item I want to change by using the array name and the index number inside square brackets. For books, that's 0. Then I assign a new value to it, the same way I would with a variable, by using the equal sign followed by the new value, in this case magazines. After this change, let's check what our array looks like now in an alert. See? The first item is now magazines instead of books. We've successfully changed the value of the first element. Arrays are especially useful compared to primitive data types because they have built-in methods and properties. Let's explore one property and 4 methods today. What's the difference between a property and a method? A property provides information about the array, while a method performs some action. Soon, all this will be clearer to you. Let's return to our array of various items on the shelf. I'll use the length property and show the result in an alert. To access a built-in property, type its name after a dot. Okay, the alert showed the number 3. What does this mean? The length property tells us how long the array is, or in other words, how many items it contains. Notice that you don't have to write any special code to do this. Just provide the property's name after a dot and you're all set. JavaScript arrays have many methods and properties. Again, properties tell us something about the array, like the length property that shows the number of items. Methods, however, trigger actions in the array. Today, we'll explore 4 methods: push, pop, shift, and unshift. The key difference is that you write properties simply by their name following a dot, but methods need parentheses after their name. I'll explain the reason behind this when we discuss functions. Just keep in mind these differences for now. Let's begin with the push and pop methods and see them in action on CodePen. Let's try using the pop method on our array, and I'll show you what happens in an alert. Look what happened. Now our array seems smaller, right? We only have 2 elements left. Sports equipment is gone. Can you see what this method does? It removes the last item from the array. If I use the pop method twice before showing that alert, watch what happens. We'll end up with only books. So remember that the pop method always removes one element, the last one. Let me show you a different method now, push. With this method, we need to put something inside the parentheses. Watch this. I'll remove the previous pop method. In the parentheses of the push method, I'll write the number 5. Let's see what happens. We now have all the previous elements, plus the number 5 at the end. What happened here? We added the number 5 as the next element in the array. Let's return to the array's original look. I'm now removing the push method. I'll show you 2 more methods. Let's start with shift. Watch what happens when I use it on our array. This time, books, the first item in the array, is gone. Now it's time for the last method, unshift. Just like with push, we need to put something inside the parentheses. This time, I'll enter the string cookies. Let's see what happens. Look, cookies now appear at the beginning of the array. To wrap up, let's review the methods we've looked at. Pop removes the array's last item. Push allows us to add an element at the end. It's important to specify which element we want to add. Shift and unshift are similar to pop and push, but they focus on the first element of the array, either removing it or adding a new. Now that you understand these array methods, it's time for a short task. Here's your mission. Imagine you have an array of fruits in your kitchen. You want to rearrange it so that the fruits you need to eat first are at the beginning. Your goal will be to use the methods we discussed to rearrange the items. On the slide, you see the initial state of the list, but below is the final result you should achieve. After each operation, display the array's current state in an alert to check if you achieved your intended effect. Use as many methods as needed, and take as much time as you need. If you're really stuck, keep watching for the solution. Ready? Start now. And how did it go? Here are the steps I would take to get there. First, I would use the pop method to remove the oranges from the end of the list. This action leaves us with bananas and apples. Next, I'd use the unshift method to add oranges back at the beginning of the list. And that's it. The list now looks the way it should. If you found a different way to get the same result, that's also great. Congratulations if you succeed. Great job! We can move on to the main lesson topic, loops. What are loops and why would we want a computer to repeat actions? There are many uses for loops in programming. They're used quite often. Loops allow us to repeat actions without rewriting your code again and again. Think of a loop like a smart photocopy machine that not only copies your documents, but also knows exactly how many copies you need and stops when it's done. For example, if you're planning a party and need to send invites to 50 people, writing each invitation by hand would be a big task. A loop in programming can handle such repetitive tasks automatically, so you only need to set it up once. Let's start learning about loops with something simple, like counting from 1 to 5. I'll set up alerts for each number. First, I create an alert for 1, then 2, and so on up to 5. When I run this, the alerts for these numbers display one after another. This example is simple because we have only 5 numbers. But what if we wanted to display 50 numbers like this? That would require writing a lot of repetitive code, right? It's always the same, an alert, only the content changes. What would this look like using a loop? Don't worry if you don't understand everything at once. We'll cover it step by step. I run this code now. Once again, the numbers 1 to 5 show up in alerts. We achieve the same effect with much less code. Let me explain what we have, but we'll get into the details soon. We have the word for, then in parentheses we set up a variable number starting at 1. We specify that it should go up to 5. Then you see something strange with 2 pluses. Inside we have an alert. Now, what if we want to display 50 elements? You remember doing it by hand. It would be a lot of work, right? With a loop, I only need to change one thing, from 5 to 50, and our program will display 50 alerts. It doesn't matter how many items we want to show, it's still 3 lines of code. Here's the loop in action. This entire code block is a loop structure. It starts with the word for, similar to how a conditional statement starts with if, right? Inside the parentheses, there are a few elements. They always look like this. You just change the parameters. The first part is the initializer, our starting point, where we create a variable with let, never use const here, and assign it a starting value. In our example, it's 1, because we want to display numbers from 1 to 5. After the semicolon, we specify how long the loop should run, like setting how many copies you want from a photocopier. We've set it to run as long as the number is less than or equal to 5. And after another semicolon, you see the word number with 2 pluses. It means add 1 after each loop cycle. How does it work in practice? We start at number 1, right? Before each loop cycle and running the code, the computer checks if our condition is met. If the number is less than or equal to 5. If yes, our loop runs and an alert with the number 1 appears. After that, 1 is added to our number. The loop runs again, this time showing number 2, and so on until the condition is met. After that, the loop stops. Let's get back to the double pluses. You know this operation as number plus equal 1. Yes, it's exactly the same. It's just a shorter way to write it. And here's something interesting. In real-world JavaScript, this code often would look like this. Using the I letter is a common convention in JavaScript that many programmers use for simplicity. It's often a shortcut for index or iterator. However, we use full variable names in our course. It helps you understand how loops work. You can name your variables whatever makes sense to you. The key is understanding the code you're writing. I mention I because it's commonly used and you're likely to see it often. Now that you've learned the theory, it's time for you to do some practice. Your task is to create a loop displaying alerts with numbers from 3 to 10. How do you do that? If you're not sure, watch the loop section and my example again, then change it to show numbers from 3 to 10. Are you ready? Pause the video and get started. How did it go? I'm sure you did great. Here's how you can adjust the existing code. In the place where we create the variable number at 1, change it to 3 because that's where we want to start. Then change the number 5 to 10. And that's all. Everything else remains the same. We increment the number by 1 after each loop and the alert is still correct. What if we wanted to display a piece of text multiple times, 3 for example? This time we'll use the variable called I. Here's how the code would look. If we want to display the text 3 times, we start from number 1 and the loop should continue until I equals 3. Let's test this in CodePen. I type this code and run it. Okay, the message appears once, twice and 3 times, exactly as expected. It works perfectly. So far, we've been using loops with numbers. But the real power comes from using loops with arrays. This combination is most commonly seen in a developer's work. Let's see how this works. Let's return to the example of inviting friends to a party. You want to invite 50 people and you know it's a lot of work. How can we make this task easier using a loop and an array? First, we'll write an array of friends' names. Let's call it friends' names. Let's write down 5 for now. We want to send an invitation to each of them. Now we'll create a loop based on what you've learned. We start with 4 and set the starting point inside parentheses. For arrays, we deal with indexes, the positions of elements. The first item is at index 0, then 1 and so on. We start at index 0, which is Alice, right? Then, after a semicolon, we set how long the loop should run. We want to send an invitation to every friend. Let's count how many we have. There are 5. How do we write that? The loop should run until the index is less or equal to 4. Why? Because starting at 0 changes everything. At index 0, we send the first invitation. At index 1, the second, and so on, until Julie, who will receive the 5th invitation and her index is 4. Finally, we do what we always do in a loop. We add 1 to the index with each loop round, moving to the next array element. This way we can automate sending invitations. Moreover, inside the message, because we insert the correct value from the array, the correct name will display each time. Isn't that great? Check it out for yourself in CodePen. I'll type in this code and run the program. As you can see, alerts display friends' names one by one. But we are not done yet here. The loop is fine for now, but what if our array changes? Remember, in JavaScript and programming in general, we want to write universal code. If we added 2 more people to the array, what would happen? They wouldn't receive invitations. Our loop now only sends 5 invitations. Anyone at index 5 or 6 would be missed. We don't want to keep changing the loop to fit new numbers. There's a smarter way to solve this. We can use what we know about the array length property. In our initial example, when we had 5 people in the array, what do you think is the length of this array? After counting everyone, the length is 5, right? We want to send invitations to every person based on their index number. The last person's index is 4. So the index should be less than the array's length, right? Now if we add or remove a few people from our array, the loop will always run for everyone without missing anyone. This approach is very flexible. We wrote the code once, which works in different scenarios. Make sure to remember it. When working with arrays, always start at 0. In the previous example, we displayed numbers starting at 1, but if you do that with an array, you'll skip the first element. The for loop is very common in JavaScript. It's also a bit old school and can be complicated. But because you'll see it almost everywhere, you must understand it. Of course, JavaScript loops don't end with the for loop. There are many more like the while loop, for in, and for off. The for loop, however, is very universal. You'll learn for sure about other loops in the future, but I'll keep it simple for now. Learning one method and mastering it is a very good approach. Finally, I have another practice task for you. If you need to, watch again the part where we discuss loops. Do you remember the fruit list from the previous mini exercise? We have oranges, bananas, and apples. Now your challenge is to create a for loop that displays the names of these fruits as alerts one by one. Remember to include all the fruits. You can look back at the examples we've gone through. Pause the video, don't rush, think about how you can solve this and start coding. How did you do? Compare your solution to mine. I started at index 0. I set up the loop to run as long as the index is less than the array's length. Inside, I put an alert that displays the fruit name. If your code is different, for example, you set the condition so the index is less than or equal to the array's length minus 1, that's also a good solution. Oof, this episode was tough, right? I know loops and arrays are not that easy. But you are doing great. Keep it up. Today, you have just one more short video about good practices in JavaScript and 2 cool exercises left. Be proud of yourself because you can now write more complex code. See you soon! Hello, Coder Woman! This episode will be a bit different from our usual JavaScript sessions. I've created this video to discuss a few things that will prepare you for the upcoming days with JavaScript. Here's what you'll learn in this episode. First, we'll move from the console and CodePen to writing JavaScript in the code editor. I'll show you how to create a file where we'll write our code. Next, you'll learn a new command, console.log. In future coding, we'll use this instead of the alert to test our code. Then I'll teach you how to write comments in your code. Comments will help you understand what you meant when you come back to your code later. Finally, I'll go over some guidelines for writing JavaScript code. While you have a lot of freedom in coding, programmers follow a few rules. Now that you know a bit about the language, it's the perfect time to learn these standards. It might also resolve any doubts about how to write code. As you can see, we have much to cover, so let's get started. First off, we'll move our work to VS Code. To make things easy, we'll start a new file in your existing portfolio project. First, we need to create a file. Click the New File icon in the upper right corner and name it script.js. It's a standard name for a JavaScript file. Next, we need to add it to an HTML file to make it work, just like we did with CSS files. This time, however, we'll use a new element called script. This tag allows us to add JavaScript code to HTML. You can either link a file or directly write JavaScript within these tags. Just write your code between the opening and closing script tags. But this time, we'll link the file. To do this, put the src attribute in the opening tag and give the path to the file. In our case, it's simply script.js, as it is in the same folder as the index.html. And that's it. We've set everything up in the editor to start writing JavaScript. Let's check if it works. Let's type something familiar. Create an alert with the message "Hello World." Let's save the file and see if it works. Yes, the alert appeared on the portfolio website. Everything's ready. Okay, let's move on. Now I'll introduce you to your new best friend in JavaScript, the console.log method. It's similar to an alert, but much better because it doesn't interrupt your work by needing you to click OK. With this method, we can display different things in the console. Let me show you an example. I will now switch the alert to console.log, save the file, and go to the website. Let's open Chrome DevTools and move to the console. See, the message "Hello World" is there. Great, right? With the console.log method, the console is your best friend in coding, testing, and debugging. On the right side, you also get information about where the displayed message comes from. The file javascript.js at line 1. That's where our code is. And if you click on the file name, you can see all its contents. We only have one line of code right now, but if there were more, we would see that too. The console.log method is great for detecting errors. For example, in the script.js file, I write something I know is incorrect. Let's say I create a variable and instead of 1 equal sign, I type 2. First, VS Code signals that something is wrong. Can you see how the equal signs are highlighted in red? If you hover over it, it explains the error. But let's suppose we didn't notice this error in the code. I'll save the file and check what we have in the console. There we have a syntax error, unexpected token. And clicking on the file name shows the code. Do you see the red icon next to the line? It shows exactly where the issue is. Thanks to console.log and the console, we can effectively eliminate errors in our code. From now on, we'll write even our test code in VS Code and use the console.log method instead of showing alerts. Let's move on to the comments. Remember from previous lessons that we can make comments in CSS too. We used these symbols and wrote the comment text inside them, describing different sections of the project in the CSS file this way. In JavaScript, we can use the same symbols to make comments. The method we used for CSS allows us to write multi-line comments in JavaScript. I can write lots of text here and create new lines. This way, I can also turn multiple lines of code into a comment. Why would you do this? Sometimes when building programs, you need to check how they work with and without some code block. Commenting out code this way is also great for finding errors. That's how we create multi-line comments. To make a single-line comment, we start the line with 2 slashes. Everything in the same line as these slashes becomes a comment. You can also add these comments after some code or even in the middle of it, not just at the beginning of the line. And remember, the computer completely ignores your comments. They are just for you or other developers who might work on your code. Finally, let's discuss a very important point. JavaScript is very flexible. You can think about writing JavaScript code as writing a book. You put your unique style into the text. For this reason, code from different programmers might do the same thing, but look a little different. The code you write is like your professional signature, so it's worth learning to write it with high quality. Writing code that runs fast and is easy for computers to process, and is also easy for other programmers to read, can be a challenging skill for developers. That's why there is a set of best practices for coding that programmers try to follow. In this course, you will see 2 episodes on this topic. In the first one, we focus on the basic rules. In the second episode, I will tell you about best practices related to more advanced topics. I've divided the style guide into sections and will show you good and bad code examples. I'll also teach you how to install and use a great VS Code extension that handles formatting for you. Are you ready? Let's get started. 2 primary rules for coding are consistency and clarity. Consistency means sticking to one style of writing. Clarity, or writing clear code, involves several things. It's how you name variables and use white spaces and indentations. It's similar to formatting a document in Microsoft Word using paragraphs, bold text, and different font sizes. We'll go through some guidelines now. Some will be familiar to you, while others will be new. You don't need to memorize all this. Writing more code will help you make these rules a habit. First, let's talk about variables and naming. Use const for variables that won't change, let for variables that might change, and avoid using var as it's old and problematic. The only exception is when you are working on older code. To maintain consistency, you might use var. Another good practice is to organize your variables by their types. Group all your const variables together and all your let variables together. Also, don't create variables that you won't use. It might seem obvious, but it's easy to leave unused variables in your code. Just double check to make sure. Now let's talk about naming conventions. Please avoid one-letter names or unclear ones. Try to describe what the variable or array is and what it does as clearly as possible. And remember to use camel case when naming things. Okay, let's move on to code blocks. A code block is everything that is inside curly braces. Curly braces are not just for show. They help segment your code, improving organization and readability. Everything inside a set of curly braces should relate to the same segment of your logic, separated from other parts. We'll explore this more when we discuss functions. It's important to use curly braces and to format them as you see on the slide. Don't put everything on one line. After the opening curly brace, start a new line. The closing curly brace should also be on a new line. For if-else blocks, the else statement and its opening curly brace should be on the same line as the if block's closing brace. Technically, it's not wrong to place it on a new line, but keeping it on the same line is a common practice. A great way for beginners to learn JavaScript is by reading other programmers' code. I believe it's an underrated but effective learning method. If you want to be an amazing programmer, read and train yourself with as much code as possible. Writing code is important, but reading others' code is just as useful. It's like reading books by other authors before you write your own novel. Okay, let's return to the style guide. The next thing I want to discuss is the use of white spaces, the empty spaces you create by pressing the spacebar. We use white spaces a lot in coding. You might have noticed that I often include spaces when I write code for you. It's a good practice because it makes the code more readable. Here are some examples. First, if you're creating a code block, the entire content should be indented, just like a paragraph in a book. We create this indentation with 2 or 4 spaces, meaning 1 or 2 hits of the tab key. And here's a fun fact. Among programmers, there are discussions about which is better. It's almost a war. There is the tabs team versus the spaces team. I prefer using spaces, and here's my advice. Whether you use tabs or spaces or indent with 2 spaces or 4, the more important thing is to indent at all and keep your code consistent. Stick with whatever you choose. I prefer 2 spaces, and that's how I write code in this course. Where else do we put white space? If we have an if-else statement, a loop, or anything with a closing parenthesis followed immediately by an opening curly brace, put a space between them. Also, put a space between the opening parenthesis and the words if or for. The elements inside the parentheses should have spaces between them, but not at the beginning or end. Don't add spaces between square brackets either. For an array, for example, put spaces after commas, but not at the beginning or end of the array. Another place we add spaces is around operators like the equal sign, the addition sign, and similar operators. By placing spaces between them, you can see how the code becomes more readable. Next, let's talk about semicolons. As I mentioned before, you should always place a semicolon at the end of the line. However, there is an exception. You don't need a semicolon after the closing curly brace in loops and conditional statements. Now here's a new and important tip. Let's say you're setting up a variable you need in your code, maybe to display it in the console. You must remember to define that variable before you use it. Define all necessary elements before using them. What happens if you don't? Let's take a look. I typed a console.log with a variable first. Then in the second line, I declared it. Let's see what happens in the console. We have an error. Reference error cannot access my variable before initialization. When the console tries to display the variable, it doesn't exist yet because the computer reads the code line by line. This is very important, so make sure to remember it. Now let's get back to the comments you just learned about. You know how to set up single-line and multi-line comments. Also, when writing a comment, start with a space to make it clearer and more readable. Developers often also use comments to communicate with each other, and they often use prefixes to do this. The 2 most common are fix me and to do, which are always written in uppercase before the comment. This helps developers quickly understand what needs attention in the code. Fix me means something is broken and needs a solution. To do means something needs to be done but hasn't yet. We might not use them in this course, but you'll likely see them in other coders' work. Lastly, I want to show you how to install and use a great plugin in VS Code. Go to your code editor, find the icon with cubes, click it, and in the search bar type Prettier. It's very popular. Just look at the millions of downloads. Click Install. We'll set it to work every time you save a file. To do this, go into the editor settings and type Save in the search bar to find what we need. We need to check the option Format on Save. Now go to the JavaScript file. Right-click and choose Format Document. The editor will ask what format you want to use. Choose Prettier, the plugin we installed, and that's it. You do this operation only once at the beginning. Now every time you save a file, it will work automatically. I'll show you how it works. For example, I made incorrect spaces like this. Now when I save the file, watch what happens. The editor automatically adds the missing spaces. Great, right? That's not all. If you write something like an if-else statement, I'll write one quickly without following the style guide. After saving, the plugin fixes it with all the new lines, indents, and spaces. Use this plugin. It's an amazing tool for learning to write JavaScript. You have a private teacher in your code editor ready to help you write good code. Okay, that's all for this episode. Don't worry about remembering everything right away. And please don't even try to. Just keep in mind that this video is a collection of tips and you can come back to it anytime during the course. Feel free to watch it multiple times. You only have to do your homework now, which, by the way, is really great. See you next time.